Good morning, viewers. I am Dr. S. Chatterjee, Professor and Head of Electrical Engineering Department, NITTTR Chandigarh. Today I am going to discuss with you the non-conventional sources of energy and their importance. Let me tell you that energy is one thing which tells the index of any country, and that is a very important commodity. I would say energy is a commodity, and we can equate energy with money. Whosoever, which country is producing maximum energy is the richest, and out of energy we really mean, if you say energy, we mean electrical energy. Let us see what is there for non-conventional sources of energy and their importance. So, I would say that the energy is generated by two ways. One is the conventional method and another is the non-conventional method. The conventional method, you have thermal power generation, you have hydropower generation, you have nuclear power generation, and so on and so forth. But these are all by burning some fuel. That is why we say that it is not renewable energy. Another kind of energy could be by using renewable energy sources. That is, the source which you are using for generating energy will be renewable in nature. For example, light, sound, wave, etc., etc. Let us see what is renewable energy sources. Our power, our future. This is our power and this is our future too. So, renewable resources of energy can be defined as renewable resources are natural resources that can be replenished in a short period of time. They are solar, wind, water, geothermal, biomass. It is shown in the slide, the renewable energy. How do you get it? You can get it from solar, you can get it from cloud, that is water, you can get it from wind, you can also get it from geothermal, biomass, etc., etc. So, national power scenario, if you see, this is very important slide. If you see the national power scenario, the total power generating capacity of the country is 205,340 megawatts, which is almost equal to 2 gigawatts, we can say 2,05,340 megawatts, which is in other words we can say 2 gigawatts. Total thermal capacity out of this is 66.46%, which is 1,36,436 megawatts. Total hydro generating capacity is 39,291 megawatt, that forms 19.13% of the total generation, and out of which small hydro generating capacity is 2429 megawatt, which is only 1.5%. The estimated potential of small hydro is about 15,000 megawatt. This is very important and many people are trying to tap this potential of the country. The total nuclear capacity is about 4,780 megawatt, which forms about 2.3% of the total capacity. Now, non-conventional generation capacity, it is seen that it is about 12.09% of the total generation, which is equal to 24832 megawatts. Now, this is the energy utilization pattern of a country. The electrical energy utilization pattern reads as this, that the total maximum power generation is utilized in industry, which is 53%, the yellow band shown in the diagram. Then you have irrigation 18%, railways 3%, public light 2%, then public water 2%, commercial 8%, and domestic 14%. This is almost the total utilization of electrical energy what we produce. Now, why this energy is so important? Because it is the index of progress. Any country, whether it is a progressive country, whether it is a developed country, whether it is an undeveloped country or it is a developing country, as you will know that India is a developing country. So, it is indexed by the per capita consumption of electrical energy. Now, here I would like to point out one point, that although we are capacity of generation, we have about 2 gigawatts of power, but the per capita consumption of our country is very low, because simple reason is the population is very high, and we are even behind Pakistan, Bangladesh, Sri Lanka, etc., because their population comparatively is very less. And another irony is that the 2/3 of the total energy is consumed by 1/4 of the total population, so called advanced people who live in urban areas, and you know that 75 or 80% of the population live in suburban areas, and they have got only 1/3 of the total share. So, this is a big irony. Now, if you see it in a bar form, the installed power generation capacity, if you have renewable, nuclear, hydro, thermal, etc., with the percentage, you will see that our aim right now, thermal is almost maximum, then red is your green is your thermal generation, that is target for 2022. If you go, it is very high, it is very low. Presently it is very high, but it will go very low. Our objective is to go for non conventional and renewable energy sources. So right now thermal power I think is the 65% generation, but to time end we are buying time, so that in future we will get the target as minimum as possible. So this bar chart shows how we are decreasing the conventional power generation and we are trying to get renewable or non conventional power generation. Solar energy, if you talk of, the nuclear fusion reaction inside sun release some energy in the form of heat and light. You know that then there are some nuclear fuels like silicon, then deuterium, tritium, etc. These are the materials, when they are bombarded with neutron, they release lot of energy, and this is a chain reaction, means it is broken, the nucleus is broken in 2, then it in 4, then 8, 16 and so on. It is a chain reaction, and ultimately you obtain lot of energy, and that energy is used, that particular energy is used to make steam, heat the water and make steam. The solar energy received near earth space is approximately 1.4 kilojoules per second per meter square. This is a high, very heavy amount of energy, and this is why, because if you make the solar as constant. Applications of solar energy is solar heat collectors, solar cells, solar cookers, solar water heaters, solar furnaces, solar power plants, etc., etc. So these are some of the examples. Solar furnace has been shown. You see that solar furnace, there is a tower, and we have got heliostats which are kept, which is a bank of heliostats, and the rays is coming on that, and that has been reflected to this tower, wherein we put a parabolic mirror which acts like a concave lens, and it concentrates all the radiations into a point, and that goes to the furnace, and that way the heat is maximum obtained in the furnace. This is example of solar furnace, and this is another, this has been shown, the diagram has been enlarged, and this is the form wherein you are getting the solar energy radiated, then made concentrated at a point, and the furnace is heated. So this is one very important example of solar furnace. Then you have helis, unmanned aerial vehicles, the UAV and UAV in solar powered light. And this is another, this is unmanned, there is no man controlling it, and is automatically controlled by these helicopters. And this Australia holds one solar car which is very famous, which got a prize also. It is known as Nuna 3. This is completely solar based. Then comes the residential solar power. Residential solar power means how you use solar power for residential heating and electricity generation, using the sun to heat your home. Let us see, solar thermal power plant outside Seville in southern Spain. This is the way they are getting it. Again, it is a bank of that heliostats, and it is radiating the power, the solar radiations into that tower which is shown there, and from there the solar tower is about 115 meters, which is 377 feet tall, and surrounded by 600 steel reflectors. These are known as heliostats. They track the sun and direct its rays to a heat exchanger, that is known as the receiver, which is number 2. It is shown as number 2. It converts concentrated solar energy from the heliostats into steam. So that water is being heated, and it is steam is produced because of that heavy amount of heat which it is receiving. And then steam, third part is the steam. Steam is stored in tank and used to drive turbines that will produce enough electricity for up to 6,000 homes. It can cover 6,000 homes. This is a very good example in Seville in southern Spain. Then comes the solar thermal plant in Spain. Spain is one country which has used maximum of solar energy. Here also this is the same example, the solar panel is there, through which the heat is being converted into electrical energy, and then this is heated, the steam is being produced, and then the turbine is being run and the electricity is generated. So, this is another way of generating electricity. This is also used in solar plants in Spain. Despite the fact solar energy is totally pollution free, you see solar energy is 100% pollution free, because there is no burning of any fuel, and it is green energy, it is known as green energy, and available in great abundance. Another advantage that it is available in abundance, at least in India, a country like India or Africa, something like that, we have lot of solar energy present, and it is in abundance. It has not yet become commercially popular because of the following shortcomings. What are the shortcomings? Let us see. Solar radiation, which is energy available per unit area, being rather weak, collection of solar energy is too costly. This is very costly, and that is why we say that it is not effective. And another thing, its efficiency is also not very high, it is poor efficiency. Solar radiation is neither uniform nor continuous in nature. So, these are some of the shortcomings. Efficiency is also poor. Because of this, the solar energy is not very popular, this technology is not very popular in the world. Then comes the photovoltaics. Photovoltaics means you have the silicon panels, wherein it is that front contact is shown, the light is sunlight is coming on it, and it is placed on the rooftop of the house. Then you have that converter, which is converts that energy is converted into electrical energy, and the battery is charged. When the battery is charged, the battery output is given to the inverter, which converts the DC, which is DC output of the battery, and it is fed to the AC units, AC loads by the inverter. So, this is the general principle of photovoltaic cells, photovoltaics we can call it. Then comes the next energy, which is known as wind energy. It is the fastest growing source of renewable energy, one of the fastest growing and one of the most important source of renewable energy. Let us see history and definition. Let us go for the history. It was first used as early as 5000 BC, before Christ. So, it is not a very new technology, it is a very old technology and very established technology too. It was first used to generate electricity in Denmark as early as 1890. Wind is a form of solar energy caused by uneven heating of atmosphere by the sun, irregularities of the earth's surface, and rotation of the earth. You see, this is very important. When I say wind is a form of solar energy, it looks very funny, it sounds very funny, but yes, it is a fact. What is happening is the uneven heating is going on in the atmosphere by the sun, and irregularities of the earth's surface is also there. So, the earth comes to a rotation, and that produces wind. So, it is also an offshoot of solar energy, but it is not very regularly available in all the places. Some of the places it has very high speed wind, some of the places it is very low, some of the places it is 0. So, it is a very irregular sort of energy, but it is there. The amount of speed of wind depends on the earth's terrain and other factors. This is very important. How much you get, the speed and the amount of wind. Sometimes we call it breeze, sometimes we call it thunders, and it depends on the speeds and how much you get. So, see, these are the factors, earth's terrain and some other factors, which tell you that how much and how much amount of your this thing is available and what is the speed of the wind. So, there can be two types of wind turbines. Naturally, when you are producing hydro power generation, you are using water turbines, hydro turbines they call it. When you are using thermal power generation, you are using thermal steam turbines or thermal turbines, and in case of wind turbines, you use wind turbines. They are of two types. One is the horizontal axis wind turbine, another is the vertical. So, this is horizontal axis wind turbine, the axis is horizontal, you can see in the diagram. Then the vertical axis wind turbine, it is a vertical axis, the axis is not horizontal, but vertical, you can very well see it from the slide. Now, let me tell you one thing, whenever you are using more windmills at a place, it becomes a wind farm, they call it wind farm. So, it is not possible to produce that much of electricity with the help of only one windmill. So, you have lot many windmills fixed at a point, which becomes the wind farm, and naturally some of them are rotating high speed, some of them are not rotating high speed, some of them are not at all rotating. So, altogether that produce some electricity, and that is being utilized. So, that is known as wind farm. So, this is a cut view shown for how the steam turbine looks like, this wind turbine looks like. These are the different parts, the blades, the rotor, the pitch sorry, the brake, then low speed shaft, then gearbox, then generator, then controller, then anemometer, then wind vanes, then and other parts are there. So, this makes the total parts construction, it shows the total construction of a wind generator. The overall view is like this: the wind generator or the wind turbine is placed there, and it is the output is being fed to the transformer section, and there it is the point is also earth, and from there it goes to the transmission lines. These are the different parts of the turbine, it is shown like this in this turbine. Now, let us see, there are certain advantages and disadvantages of wind turbines. Wind is free. First advantage is wind is free. Wind farms need no fuel. So, it is almost free, almost free, because it is a nature's gift and there is no money required for it. So, this is the biggest advantage. Then second advantage is it produces no waste or greenhouse, we can call it, the no waste or greenhouse gases are not produced. So, it is a very neat and clean energy. Then land beneath can usually still be used for farming. You see, the wind turbines are standing, and beneath the land is there, it is free from anything. So, you can use it, reuse it for farming also. This is a very big advantage. Then wind farms can be tourist attractions. It looks very beautiful. When you go and see the wind farms, it looks very effective, very effective in nature, and it looks very beautiful also. The good method of supplying energy to remote areas. This is a very good method of supplying energy to remote areas. Some of the disadvantages we can read from this slide. It is not always predictable. Sometimes the wind is blowing, sometimes it is not blowing, and many times it is 0. So, it is not always predictable. Price of land is a very big disadvantage. The land price is very high. So, naturally it takes a lot of price for that. Changing landscape, the landscape, suppose it has been designed for something particularly, and if you want to have your windmills or wind farm there, so there is naturally the landscape will change, it is a disadvantage. It can kill birds because of its terrain, because of its shapes, because of its design. The birds are normally killed by this type of arrangement. It can affect television reception if you live nearby. So, with some of the area which is nearby, the television receptions are affected badly. Noisy, a wind generator makes a constant low swooshing noise day and night. It is a constant noise and all the time you get it. Now, this is Dubai skyscraper with rotating floor. Now, this is a wonderful building, you can see here, it is a wonderful building, and this rotates itself. Now, the windmills are not required, the building parts you can see from the second photograph of the slide that they are all different in shapes. So, some part is rotating at 30 degrees, some are 15 degrees, some at 45, some at 60 and so on. So, what is happening is according to the breeze blow and according to the speed of the breeze or wind and according to its orientation, the building itself is rotating. So, what is the advantage? Advantage is you do not have to keep a controller for its frequency control. The frequency is maintained constant at all the stages, and naturally it is a very big advantage. This is a very fantastic building built in Dubai skyscraper, which is rotating, which has rotating floors, and accordingly the floors rotate, and naturally you get a constant wind energy out of it. Now comes the hydroelectric power, India's leading renewable energy source. Let us see what is hydroelectric power. History and basics, it is all known to you of course. The earliest inference from 4th century BC Greek literature, hydro comes from the Greek word for water. So, it is water related, you all know it. By 1980 accounted for 25% of global electricity and 5% of total world energy use, totaling 2044 billion kilowatt hours. So, this is a very big statistics which has been obtained. water flows from a high potential energy high ground to lower potential energy lower ground. The potential energy difference is partially converted into electric energy through the use of a generator. This is a known fact. When the potential similar is the case with electricity, the electricity flows from higher potential to lower potential, and in case of water it also flows from higher potential to lower potential. There are two major designs in use that utilize water to produce electricity. Let us see. Hydroelectric dam. You see the dam is there which is to stop the water, and the water is thrown at the blades of the turbine from a very big height. So, naturally the potential energy which is had, it is converted into for rotating the turbine, water turbine, and in turn it rotates the generator, the electricity is generated. So, river is connected, turbine is there, penstock is there for filling the water, and intake gate is also there. Suppose the water is not required much, the gate is closed. Suppose it is required much, it is opened, and like that is controlled. So, this is the powerhouse in the middle, generator and powerhouse, wherein you generate the power and then electricity is transmitted through long distance power lines. Hydroelectric dam, what is the advantage? The advantages are the energy is virtually free. There is no, you do not have to pay for it. No waste for pollution, pollution. Since there is no pollution, so there is no waste. It is a very big advantage. Reliable, it is very reliable. Once installed, it is very reliable and it continuously generates. Can cope with peaks in demand. Suppose there is a peak demand, it can cope up, and it is very good in high demand situations. Can increase to full power very quickly, unlike other power stations. This is a very big advantage. Electricity can be generated constantly, uniformly, and there is no break. You can always generate electricity. What are the disadvantages? Is expensive to build, because dams are to be built and then water turbines are to be installed, lot of other constructions are required. So, expensive for the building part. Environmental concerns upstream and downstream. This is another example of pumped storage plant. Suppose in peak time you need more water, so you will use more water for the turbine to rotate more and more electricity is generated. But there can be a lean time also. For the lean time not much power is required, water is not much required naturally. So, that water which is extra has to be pumped and it goes to the reservoir. So, that is known as pumped storage plant, and of course, as you see the switch yard is there, the power is transmitted through transmission lines. Pumped storage plant has the advantages and also disadvantages. The advantages are little effect on the landscape, no pollution of waste. Disadvantages are expensive to build, as I told you earlier. Once it is used, you cannot use it again until you have pumped the water back up. So, this is one disadvantage, and good planning can get around this problem. So, you have to you can overcome this problem, but for that you need a very good planning. Important concept is these plants are not really power stations, but a means of storing energy from other power stations. This can be a backup sort of power plant. Now comes the ocean energies, waves, tides, ocean currents, ocean thermal energy. These are some of the things which form the ocean energies. General information, for general information, you can note that 70% of Earth's surface is covered by oceans. This is not known to you. Huge potential, it has a very huge potential, because 70% of the Earth's surface is covered by oceans. So, naturally it has a very huge potential. A mere 0.1% of total energy potential in oceans would satisfy all of mankind's energy needs 5 times over. Now, this is the point where you can have a lot of debate, a lot of research can be done, because this is very important. You see that 70% of the Earth's surface is available in the form of oceans, and then naturally it has a very huge potential, and only 0.1% of the total energy potential what the ocean has will be able to satisfy all the mankind's energy needs 5 times over even. So, if this energy is tapped, it is wonderful, and naturally it can serve the mankind in a very well manner. Exploiting location and natural geography, when the winds blow across Atlantic west to east and create bigger waves, more energy potential. areas for underwater currents and tides. So, this is the example of that attenuator. You keep it in the ocean, and you know ocean has its waves other than the tides. It is not tide wave, these are continuous tides waves, and they can affect the attenuator and absorber also, and accordingly this wave, that energy what is had, which is a continuous form of energy, can go in, and it has been used for water heating, for any oscillating water column, and then overtopping device, etc., etc., and further electricity can be generated. You can see one 2008 Aquarate, this is the company which builds it, it is a very famous company. Wave power, waves push high pressure oil through hydraulic motors to generate electricity, fed to grid via underwater cable. This is what is happening in wave power. Then wave forms 30 megawatts per square kilometer, enough to power 20,000 homes. This is a wonderful figure. It wave forms 30 megawatt per square kilometer it can give, and in this which is more than enough to power 20,000 homes. It can illuminate, it can give all required electricity. All systems manipulate wave motions to power hydraulic pumps or spin turbines. This is that example, we put it on the ocean beaches and all, and we can continuously utilize electricity out of it. Now comes the tidal power. Now mind it, tidal power and wave power are two different things. Wave power is that which is continuous, it is always available in the ocean, and we are tapping that particular wave, and that wave is used for creating the energy and getting converted into electricity energy. And tidal power is that which sometimes happens, there can be a high tidal, there can be a low tidal. So, damming storages water flows through turbines. One method of ebb generation, high and low tides are very predictable, can only produce electricity at certain times. Not many places in the world where it is efficient, 5 to 10 meters difference between high and low tides, and high cost. This costs very high. The technology is not cheap, it is not economical, it is a very costly affair, and it negative impact on estuarine ecosystems are also a very negative point of this. Ocean thermal energy conversion, OTEC. Hawaii can exploit this technology because of its location near the equator. Sun heats water to depths of 100 meters to temperatures around 24 to 30 degrees Celsius. This is very important statistics, very important data. It can heat water to depths of 100 meters, even at water depth at 100 meters can have temperatures around 24 to 30 degrees Celsius, are flashing into system. Cold water from deeper in ocean condenses the steam, produces desalined water. Now, desalined water is because of the cold water which is in the deeper ocean that condenses the steam and that produces this kind of water. So, this is the technology in ocean thermal energy conversion. This is the diagram, one single line diagram. It shows how pump is being used, and then an evaporator is there, a turbine is there, electricity is generated and working. All these models it is same like that, but here the energy what is being used is through ocean. Then comes geothermal, exploiting Earth's temperature to produce electricity. Means geothermal means when you go deep into the earth, there are lot of under beneath soils which is hot in temperature. So, the temperature is maintained when you go deep into the earth, that is known as earth temperature. When you exploit that earth temperature to produce electricity, it is known as geothermal energy. Okay. So, it is the energy harnessed from hot rocks present inside the earth. As I told you earlier, when you go deep into the earth, there are rocks, there are soil layers, then earth, then harness, then your rocks, etc., etc. And as you go deep, that is lot of energy in the form of heat is available, and that heat is harnessed from hot rocks present inside the earth. This is another, this is again the generation plant. What you have a cooling tower, everything is like that. You know, thermal power generation, it is, system is exactly like that, only the energy what you are using, that source is different, that is why it is different. Otherwise, the structure of the system is same. Now, let us see what are the advantages. Reliability, first advantage is reliability. It is a very reliable system, because the earth's heat provides a constant source of energy. It can never go waste, it is always there. You cannot say that it is sometimes there, sometimes not there, it is always present. Hence, it is a very reliable source. Low impact on environment, it does not have any impact on environment. So, very small impacts can be there. So, we can call it that it has a low impact on environment. So, it is a very clean technology. Room for improvement, 2300 megawatts in 2004.